good day, folks. Welcome to Stat 270. This is a short presentation on the chapter number 2. And in chapter number 1, you might have learned some of the basics of statistics. And just wanted to tell you, if you don't know from where to find the chapter 1, I posted some presentations on chapter 1. Go through those presentations, and that will be sufficient enough to learn things about chapter number 1. And if you still have some questions about chapter number 1, you can always come back and see me in the tutorials, which I run on every Saturday from 12 to 4 p.m. in the SATE library. All right, let's look into chapter number 2. In this chapter, we will talk about how to make the tables. So first of all, this question is given to me: construct a frequency and relative frequency table. And we are given the data. The following data shows the preferred bread types of the 20 shoppers. Just wanted to tell you, these are the questions which I'm taking from the book. So this question, you will find it in the book into chapter number 2 also. And the following data is given to you. So there are different types of breads which uh, have been sold by the manufacturer, and the WB stands for the white bread, WW stands for the whole wheat bread, and WG stands for the whole grain bread. And construct a frequency distribution table for the given data, and then the relative frequency distribution. So how are we going to convert it into the table? So first of all, when you will be doing this, again, this is how your solution should look like. I'll just show you also how you're going to do it. So you're going to press X here, and then f of X here, f of X, then put it in the bracket, and then here you can write WW, here you can write WG, and then the next one is WB. And then how many of WW means white, WW is whole wheat bread. How many of the whole wheat breads are there? So you can do a command equal to count. Uh, count if, that's the command you're going to use. And the range is range I posted here. So again, if you are asked a question something like this in exam, and then kindly put all the information from the D12 onto your Excel sheet. So this is what you have to do. All these numbers are posted it, or the alphabet, shall I say, I posted it down here. And count if the range is this one. This is the range which I'm using, comma, and the criteria becomes, criteria is WW. So quotation, it is WW. If it is alphabets, you always have to put it under the quotations. Okay, and then press enter. So it's the 8 of these, and then I can move these down here. And now, just before I move also, I need to make sure that I take the absolute reference of these, and Fn F12. So to take the absolute reference, I'll press Fn F12. For some of you guys, it may be directly only not F12, sorry, my apologies, F4. So it may be, oh, 1 second, let me just quickly redo it. Fn F4. Yeah, for some of you on your computer, it may be only F4. And if you have any confusion with regards to how to use the Excel, please see me in the tutorials. That will be mandatory for you if you don't know how to use Excel. And then now if I go to the next one, in this one, what's going to happen is here, I should have taken, first of all, taken the absolute reference here, and now moved it downwards so that I can keep the absolute reference. Yeah, so absolute reference is here. There I will change it to WG, and it's going to change to 5. And then here I'm going to convert it to WB. So what I've done, I've converted the raw data in the table form. And here I'm going to calculate the frequency. So total is represented by n is equal to sum. I can use the command, and this will be equal to sum of all these numbers. That's going to give me 20. And now this is the frequency distribution table which we've created. Now we have to create the relative frequency distribution, RF, relative frequency. Means we wanted to convert everything in the decimal numbers. So equal to 8 is what portion of 20? That's what we are trying to figure out. So 8, this number divided by, I'll take the reference here, this is 20, and press enter. That is the 0.4, or you can call it as 40%. And for this one, 5 divided by 20 again, and then this one equal to 7 divided by 20. So you got the references, relative frequencies, and sum of the relative frequency should always be equal to 1. So let me just put it here. Sum, auto sum, you can use the auto sum here too, and this comes out to be 1. So that's how you're going to create a frequency and relative frequency distribution table from the raw data. Now please remember this thing. I'll keep on using these two words, the table and the raw data. The raw data means something is given to you in just the way it is. So for example, this down here which I've written, this is the raw data form, and this what I've created here, this is the table form of the raw data. Right, hopefully this question made sense to you guys. And now I will jump on to another questions. I'll highly recommend you to practice some of the similar questions like this from the book. And let's jump on to the question number 2. All right, so in this question we are given, let's read the question first of all. A safety measure while providing the credit, Maple Credit Union collects and analyze the credit scores of the loan application. Credit score below 650 are considered to be poor, and scores between 650 and 750 are considered to be good. The scores between 750 above 750 are considered excellent. Maple also classify the loan applications by size. Loan amount below 5,000 are considered small. Those between 5,000 and 20,000 are considered medium, and the loans above 20,000 are considered the large. An employee at the credit union randomly selects 160 loan application and summarizes the data in the two-way table. So basically what we are doing here is we are learning how the two-way table is used to answer some of these questions. So this is a two-way table which has been created down here, and based on this two-way table we wanted to answer some of the questions. So again, if you see a question like this in exam, please make sure you try to put it under the in an Excel table. And one thing I will also tell you, whenever you are solving these questions, so for example, one question on the one sheet and second question I've done doing it on the second sheet. So don't try to create a hodgepodge, means don't try to solve all the question on one sheet. So keep one sheet for every question. Okay. Now here we've created that table down here, and now I will also recommend you can see online how you can fetch the data from the picture in an Excel. Also you can directly fetch the data by taking the screenshot of this picture also, and you can find it online on the YouTube video. Now here, let's answer some of the question. What proportion of the loan application sizes are small? So if I look into the small, and what proportion means out of total, what is the proportion of the small application? So that is clearly, I can say 52 over 160. So if I see this number, if I double click on this one, that is 52 upon 160. That's what we did. So you can also, again, I'm going to write it here, equal to this number divided by 160, which is this number. So that comes out to be this much. And then you can convert it into the percentage form also. You can go to home page, and then from general you can convert it into percentage. So if I convert it into that is the percentage. Or you can, if you don't want to do that, you can multiply this number by 100 also. That will convert it into the percentage. One thing I want to tell you, whatever answer you are getting, please highlight it with certain colors so that I can see what is your final answer which you got. Now another thing, the second question, shall I say, What proportion of the credit scores are good? What proportion of credit scores are good? Good comes under here, so 48 out of 160. So that will be 48 out of 160. 48 out of 160. So that's how we're going to answer these questions. Now let's look into the next one. What proportion of the loan applications are both small in size and submitted by the applicants with the excellent score? Small in size and submitted by the applicants which are excellent. So small and excellent. So that is 12. So 12 divided by total number of applicants. So 12 divided by 160. Okay, because there are two constraints in this one, both small in size and submitted by applicants with the excellent credit score. All right, so hopefully you were able to understand that. Now, what proportion of the loan applications are both medium in size and submitted by the applicants with the good credit score? Both medium in size and submitted by the applicants, medium in size, medium in size, and submitted by where it is the what medium in size and submitted by the applicants with good credit score. That is 19. Okay, let's see this one, what we've done in this one. So here it is 19 upon 160. So hopefully you've been able to understand how we simplified these questions. Okay, and let me just take one or two questions from here. I'll post this file also on D2L so that you can see how I try to answer all these questions. So what proportion of the large loan applications are made by the applicants with the good credit score? It's saying, so read this question carefully. What proportion of large size loan application? What are the large size loan application? Large are 54. And what proportion of large size applications are made by the applicants with good credit score? Good credit score is 14 only from the large. 14 divided by 54. So answer for this one will be 14 divided by 54. I think that is the F. I'm not mistaken. So 14 divided by 54. That's how you're gonna simplify these questions. What proportion, now let me look into the final one. What proportion of the small size loan applications have poor credit scores? Small size, how many total are there? 52, have poor 25. So I would say 25 over 52. Let's see, 25 over 52. So please make sure when you are solving the question from a two-way table, you always pay attention to what is given to you in the question. And in some of the questions, we will also learn how to make the two-way table too. Now, in this question, if I see, let's look into this question. So what proportion of employees in each department at some limited company displayed in the chart below? Suppose the proportion of employees is given to us, okay, in this question. Suppose there are 1,200 employees, full-time and part-time in the company. What proportion of the employees are in finance? So here we are given the pie chart. So how to construct a pie chart, I will teach you also that thing. So let me go back into this sheet and talk about how we can construct a pie chart. So if I wanted to create a pie chart for this given data, so let's see, I'm creating a pie chart. So let's see, insert, and from here all the different types of charts are there. You can click here, you can click here also. It's going to open a new dialog box. I'm not sure whether I don't think you can see the dialog box, but click here. I'll tell you, you will click on insert and then click on this small icon, and it will give you the different types of chart. Or maybe let me just quickly show you under the insert, and then let me press on recommended chart. It again takes me to the same place. So, and then you can click on all charts, and then under the all charts you will see the pie chart. and then you can select the pie chart from there. So in this one, if I see I selected this 20 and 1, I shouldn't be selecting 20 and 1, so I will select only the ones which I need, this one, and insert. Again, click insert, and then the charts, I wanted to have the pie chart, all charts, and then I'll select the pie chart and press OK. So a chart something like this will open up on your computer screen. So this is the proportion, and if you wanted to show the proportions also, you can select this chart, select the chart, and then chart design. From the top, chart design, you wanted to show it the percentages also, you can show it from here, percentages, different types of views you can show it. Okay, that's how we create the, first of all, the pie chart. And just practice the pie chart with that Pareto chart and the bar chart also. I just wanted to tell you, Pareto chart means it's a bar chart, but it's in descending order. A Pareto chart means bar chart in the descending order, and this line will tell you where the 80% differs from the rest of the 20%. Top 80% differs from the rest of the 20% values. This bend in the line, that's what it tells you. Okay, so difference between here, one thing I want to tell you, difference between a Pareto chart and the bar chart is, bar chart can be, the first bar can be taller, second can be smaller, third can be even taller. That is simple bar chart. But if you put them in the descending order, all those bars, that is called Pareto chart. All right, let's move back to the question. Here we are given the pie chart, and in this pie chart, we wanted to find some data is given to us, and we wanted to answer some of these questions based on the data. Suppose there are 1,200 employees, full-time and part-time in the company. What percentage of the employees are in the finance? So here we are given, so 18%, 24%, 34%, 14%, finance percentage is missing. Total is equal to 100%. So 100 minus 14 minus 34 minus 18 minus 24, that's going to give you 10% answer here. So 100 minus 18 minus 24 minus 14 minus 34. And how many employees are in the in production or marketing? How many employees? So total number of employees are 1,200. Production and marketing. Production is 34, marketing is 24. So production plus marketing is equal to 34. 34 plus 34 plus, where is plus, 34 plus 24, and that is equal to 58. So production and marketing is 58%. Okay, in production, employees are in production or marketing, so that will be equal to, employees are in production or marketing, so equal to 1,200, multiply it with this 58%, 0.58. That's going to give you the number of employees. I think here I've done it wrong because I'm only doing it for the marketing. Here it says production or marketing. Okay, so I need to change this one. This is the correct answer. Home, and I can color the correct answer with the different color here. Let me just color it. This is the correct answer. This is not the correct answer. Home, let me just again mark it as red. This is not the correct answer. All right, now the next one, how many employees are neither in finance nor in HR? Neither in finance nor in HR, 10%, and HR is 14%. 24% of the employees are in HR and finance. So rest of the employees are in the other departments. So again, so we will add these ones, 34 plus 18 plus 24. So equal to 34 plus 18 plus 24. Oops. plus 24, 76%. How many employees are neither in finance nor in HR? So 76%, which is equal to 1200, multiply it with 0.76, which comes out to be 912. Let's look into the final. If 25% of the employees are part-time workers, how many employees are full-time workers? So remaining are 75%, and equal to 0.75 multiplied by 1200. That's going to give you the answer 900. So that's how you're going to answer the questions if you are given a pie chart. All right, let's move to the last question from chapter number 2.1. The last question is about this given chart. We are given the data, and the data is about the students studying, and they are using the peer tutoring, and some of them are not using the peer tutoring. Some of them are full-time, some of them are part-time. First thing we have to do is create the two-way table from this kind of a data. That's what we wanted to do. You can still answer the questions without making a two-way table, but if you are given a data something like this in which there are two bar graphs under one input. So for example here, full-time students using the peer tutoring and not using the peer tutoring. So there are two groups under the full-time. And same way, there are two groups down here also for the second one. I'll recommend you to draw a two-way table, so it will help you to answer the questions easily. If you don't want to draw it, it's up to you too. Now, full-time, here I mentioned the full-time and here I mentioned the part-time. You can mention the full-time and part-time on top also. On top here I mentioned the peer tutorials and no peer tutorials. And I will try to place them here. So full-time and peer tutoring. So full-time and peer tutoring, use the peer tutoring. So 255, I will put the value down here. Full-time and no peer tutoring, full-time and no peer tutoring is 198. I can clearly see 198. And part-time, and that is again part-time with the peer tutorials 355, part-time and no peer tutorials 442. And this is how we created the table down here. And then I will add the values here. So added the values, these two, and then added the values here, these two. The sum of these should be equal to the sum of these. So horizontal and vertical sum should come out to be the same, 1200 total. If you sum these two values, that's also going to be 1250, shall I say. All right, then try and answer the questions now. How many students were surveyed? So the total number of students surveyed were 1250. Okay, how many students were surveyed? How many students that were surveyed do not have the peer tutorials? So do not have the peer tutorials, do not have the no peer tutoring. 640, and the answer is 640 down here. And create the two-way frequency table, which we've created down here. And what percentage of the students, now sorry, before I move forward, it says create a free two-way table, so I have to create it also, you know. So it's always beneficial if you're going to create the two-way table, because later on you're going to use that too. What percent of the students surveyed use the peer tutoring? So let's see this one. What percent of the students surveyed use the peer tutoring? Peer tutoring is 610 out of 1250. So that is the percentage of the students which use the peer tutoring. What percentage of the students surveyed do not use the peer tutoring and are the full-time students? So do not use the peer tutoring. These are the people do not use the peer tutoring and are full-time. That is 198 upon 1250. So that's how you're going to answer these questions. So hopefully you you've learned how to answer these questions. And what I'll take one more from here. What percentage of the full-time students that use the peer tutoring? Full-time and peer tutoring. 255, I guess, full-time and peer tutoring. So full-time and peer tutoring is 255, and we've taken out of 453. So this is kind of a little tricky. I'll show you what's going on here. What percentage of full-time students? What percentage of full-time students, not the total students it's asking. So please make sure you see it, read the question carefully. What percentage of, if it was total students, then I would have used the 1250 in the bottom. Now it says what percent of full-time students. So full-time student is, total full-time students is 453, and the percentage which have used the peer tutorials is 255 over 453. So hopefully you were able to understand the chapter number 2.1. So I've taken these examples. I'll highly recommend you to do some of the examples by yourself also. And that's it from my side from chapter 2.1. I'll come back with another video on chapter 2.2. Till then, goodbye.